Hi everyone, I'm Martin and you're welcome to today's lesson on Introduction to MATLAB. Today we'll be tackling expressions, variables, and data types. Now these elements are fundamental to the structure of MATLAB and how MATLAB works. And the syntax or your understanding of the syntax and the rules of the MATLAB programming language relies on a good grasp of these early concepts and rules. So we're going to treat expressions and operators, and then we'll look at variables and then data types. Now, expressions are combinations of numbers, operators, variables, and functions, right? Or usually have one or more of these, two or more of these in an expression. Now, MATLAB evaluates them to produce some sort of value, right? And the value depends on the nature of the expression. So there are types of expressions heavily dependent on the type of operators involved in the expressions. So you can have numerical expressions. In that case, the answer will be a number or numerical value. You could also have logical expressions with logical outputs. So we are going to treat these one by one and then see how to represent them in MATLAB as well. Now, numbers, MATLAB by default uses the Arabic numbering system, and that's a simple math. If you have any background in math, you understand. You do not even need a background in math to know how to use Arabic numbers. That is the default system. So we don't do much over there. We move straight to operators. Now we look at the types of operators. They are numerical operators, relational, logical, function-based, and mixed operators. As a result, we also have numerical expressions, relational expressions, logical, function-based, and then mixed expressions. All right. So let's look at numerical operators. Now they are involved in combining numbers. Right? Numerical operators combine numbers to yield other numbers. Right? The output is usually a number, and it involves addition, subtraction, multiplication, division, and the power or exponent operator. Now these are also used in basic math. So let's take an example of this in MATLAB. If you have MATLAB open, so in our command window here, we have our command window. Now, one thing we want to do before we start is to come here. I already have it on, but your interface should look like this, right? And come here and then turn on class, right? So just right click on the empty space here. You have this menu and then you take class. Right? We'll come to that a bit later. So for numbers, we have you enter 243, hit enter, and then that evaluates to 243. So that's it for the numbers. We can add, right? So 2 plus 2, that should give you 4. We can subtract 5 minus 2, that gives 3. We can multiply 2 by 5. We can also divide. And that should give us 5. There's also the exponent using the symbol 2 exponents 4, and that should give us 16. Now, you can also combine these operators. So 2 exponents 4 minus 4. This should give us 16 minus 4, which should be 12. So I said that, yes, we get 12. We can keep on going. We can add 2. So one easy way to repeat an expression you've already entered is to hit the arrow up key on your keyboard. The arrow keys on your keyboard, the up, and then that should show you the previous expressions. You can navigate to whichever expression you want to work with, and then you continue typing from there. So now I can add 5, and that should simply evaluate to 17. So that is basic for numerical operators. Now the next thing we want to talk about is the precedence, right? So usually when you combine numerical operators in an expression, MATLAB follows a particular rule, just like we do in math as well, to evaluate these operators in order to give us the right answer. So in MATLAB, parentheses or brackets take first precedence, and then you have the exponent or power, and then multiplication and division, which go together, and then addition and subtraction come finally. So let's take an example of this. Let's go back to this expression, and if we let's look at the answer for this previous one. We have 2 exponents 4 minus 4. So this is evaluated first. Between the power and subtraction, this is evaluated first. So we have 16 and then minus 4, you get 12. Now, if that did not happen, we would have had, assuming subtraction took precedence, you would have 4 minus 4, which is 0, and then 2 exponent 0 should just be 1. So we can test that. The way to do that is to put parentheses here, and that will ensure that this is evaluated first before the exponent or the power takes effect, and that gives us 1. So now let's try something that combines many more of these operators. So let's go to exponent 4 minus 2 and plus 5 times 3 divided by 3 minus 1. We are doing it linearly so that we can see how each one of these takes effect. So by the order we just studied, this should begin with, because we don't have any parentheses here, this should begin with the exponent or the power. So 2 exponent 4, which is 16, occurs first, and then we look for division and multiplication. Really, 5 times 3 is 15 divided by 3, and that is 5. Or it could just also be 3 over 3, which is 1 times 5, which is 5 again. So between multiplication and division, it doesn't matter which one you evaluate first. You have the same output. So this should yield 5 at the end of the day. And then we are left with subtraction and addition. So we can just go 16 minus 2, which should be 14, plus 5, which should be 19, minus 1, which should be 18. So if we hit this, we have the output 18. And that is how the sequence follows. Now we can try to introduce some parentheses at the bottom here. And then if we evaluate this, let's see what we should expect. So because there's parentheses here now, this takes precedence. We have 3 minus 1, which is 2. So 2 is evaluated first. Then we go back to this, which gave us 16. And then we come back to the multiplication and division. So here we have 15. 5 times 3 is 15 divided by 2. That should be 7.5. So 16 minus 2 is 14. 14 plus 7.5, that should give us 21.5. So if we hit this, we should obtain the right answer. And we see that that differs from what we entered initially. Now you can also nest brackets. Right? So let's try this next. Let's force this to be evaluated. So what happens when you nest brackets is the most inner bracket takes precedence, and then whatever is in the outer brackets is evaluated before any other expression follows. So over here, we still start with 3 minus 1, which gives us 2. However, instead of jumping directly to the exponent, we stay because we have all of these inside the parentheses. Now, since there's a combination of these operators in here, they still follow the usual sequence. You have division and multiplication coming before addition and subtraction. So again, we have 5 times 3, which is 15, divided by 2, which should give us 7.5. And that now becomes 4 minus 2, which is 2 plus 7.5. You have 9.5. So this should give us 2 exponent 9.5. And that is 724.0773. To check that is exactly what happened, we can just directly input 2 exponent 9.5, and then we see that evaluates the same numerical value. So that is it for numerical operators. Now let's look at the other type of operators we have. So we have relational operators. Now these are used to compare part of an expression or two values in an expression, right? Two or more values in an expression. So you have the equals, not equal to, greater than, less than, greater than or equal, and less than or equal. Now, whenever you compare values, the answer is a boolean, right? A boolean just tells you whether the comparison you're making is true or false. So booleans are logical statements. So uh, that are the outputs of comparative operators or relational operators. So let's go into MATLAB and quickly try this out. So let's start with the equals. Now, for the relational equal operator, you use two equal signs, right? The single one is reserved for something else. Variable assignments, when we get there, we'll look at that. So 3, if I want to say 3 equals 5, this is the way to write it. Now, the outputs, there are two kinds of outputs you can get from these relational operators. You can either get a true or a false statement. Now, a true statement is represented by 1, a false statement is represented by 0. Right? So MATLAB does not write true or false, it writes the numerical placeholder for true or false. So if we enter this, we get 0, and that is false, and that's because 3 is not equal to 5. Right? So I could instead enter this, which is the expression for not equal to, and this should be true. Truly 3 is not equal to 5, so that evaluates to a true statement, which is represented by 1 instead of 0. You can try others. 3 is greater than 5, that should be false. 6 is less than 10, that should be true. 6 is greater than or equal to 6, that should be true. Now 10 is greater than or equal to 11, this should be false, and so on. We can also combine these expressions with numerical operators, right? So you can have 5 plus 4 equals 10 minus 4, right? And that is false. For 5 plus 4 is 9, and 10 minus 4 is 6. So that's a false statement. If we alter this and make this 1, that should give us a true statement. So you can combine them with other kinds of operators. You can also combine multiple relational operators, and something interesting happens whenever you do that. So let's say 5 is greater than 6, which is obviously false. And let's say all of that is also greater than let's try a number first. So let's say this is 5. Now this 5 is greater than 6 is false, and that greater than 5. Let's see. So this should give us a logical statement because relational operators produce logical outputs. Now the logical output here we should expect is a false. So let's see. Right, that's 0. It's false. And what happens is 5 is greater than 6 is first evaluated, right? And that gives you false. However, false has a numerical placeholder, which is 0. So what at the end of the day, what is actually compared here is 0 is greater than 5, which is a false statement. So you have false as the output. We could replace this with less than, and that should give us a true statement, right? Because false, which is represented by 0, is less than 5. So the numerical placeholders are used in these expressions. We could also try this. Let's say false. So we are going to compare a false statement to a true statement, and then we see that even between them. And so we say 5 is greater than 6, which is false. Is less than 5 equals 1, which is also false. Now, is 0 less than 0? No. So that gives us a false statement. We could say less than or equal to, and that should change the nature of the response we get is true. Right, 0 is equal to 0. So false is equal to false. So this symbol takes care of it. We could also go, if we want a true statement, we could just make this 5 and then keep this. So all that is being compared is false. 5 is greater than 6 is false. 5 equals 5 is true. So you have false is less than true. And that's true because 0 is less than 1. So that is it for the logical, the relational operators and their logical outputs. Now the next thing we will look at is logical or Boolean operators. And these are used to combine and modify conditions. And they become especially important when we are dealing with loops or conditional statements in MATLAB, which we'll treat later on. But for now, let's take an introduction to them. So we have the AND, OR, and NOT operators are represented by these symbols. So let's go into MATLAB and then see how to evaluate some of these. Now, these logical operators also output logical statements as true or false. So let's take a most basic example. Let's say 5. Now, this gives us true. Basically, any number, if it's just a single expression, is true. The default logical statement is true. Now, what the AND does is a statement is true if both the first statement and the final expression or statement is true. So 5 is true. The other 5 at the other end is true. So that evaluates to true. Now, if even one of them is false, you get false. So let's try this. Let's state 5 is less than 4. And then let's go with this. Now let's say 5 plus 5. Now this gives us false because even though 5 equals 5 is true, this is a false statement. 5 is not less than 4. So you need both sides to be true in order to get a true output. Now let's look at the OR statement. Now the OR just requires one of these to be true, right? So if we change this to OR, which is represented by this, right? This is false, however, this is true. So you just need one of these to be true, and then the answer evaluates to a true statement, right? So either this is true or this is true, and that should give you a true, or the condition is met if either of them is true. In the first case, the condition is met if both of them are true, if this is true and the other is true. In this case, if this is true or the other is true. So let's look at that simple expression first. Let's do it for OR. Right, and true statement, because both of them are true. If either of them is true, you have a true statement. So the only way OR gives you false if both of them are false. So for instance, in this case, immediately I change this to 6, then OR will give me a false statement because neither of this is true. Now that brings us to the NOT statement. Now the NOT statement is very simple. All it does is to negate the output of whatever you place in there. So if we go back to our first statement, which is this, if we can apply the NOT to the whole thing, we know that this should be true, right? It's true statement, but the only way to get a false out of this is to apply the NOT, and that gives us false. So 5 and 5 is true, and so NOT that just reverses the output we are expected to get. We can do the same for this expression. I usually like to place this in parentheses. Right, so if we recall, this yielded for an end statement, this should be false, right? Because this part is false. We need both sides to be true for it to be true. So this should have given us false. However, the NOT just reversed the false and we got a true output. We can do same for the OR statement. And same thing. Now this, both sides are false, right? This is not true. This is neither true. So this should give us a false statement. However, we have the NOT there that reverses whatever is in there. So we have true at the end of the day instead of false. Now, MATLAB has a number of built-in functions for mathematical operations, more complex mathematical operations compared to the basic arithmetic. And they're functions because they take arguments, you pass arguments to them, and then they evaluate a response, a corresponding answer. And among those, we have a few square roots, trigonometric functions, exponential functions, and so on. So let's quickly take an example. Let's start with the square root. The syntax is just sqrt, and then you pass your argument, which is simply the value you want to operate on. So it's square root of 4, you want the square root of 16. So in that case, we have 4. We could get the square root of 100. That should give us 10. Now you may not want the square root, you may want another root, say the cubic root or the fourth root or whatever root you want. In that case, the general syntax is n root the number the value you want to operate on. So we may be looking for the fourth root of 16. Then, so the value you want to operate on comes first, and then you have the root coming after. And that should give us 2. We compute the nth root of, in this case, the cubic root of 27. That should give us 3. Now, since it's general, it should also be able to give us the square root. So we could use that square root as well. And that also works anyway. So the general root function is the nth root. Now let's move on to the trigonometric functions. The general syntax, it's as they are known, you have the sine, cosine, the tangent, and among others. So the basic ones just go by the names. However, one thing to note is the argument you pass depends on the measure you are working with. So MATLAB by default expects the radians for the sine and the cosine functions, the trigonometric functions in this form. So if you want to use degrees, you need a variation of the trig functions. So let's use the sine of 30 degrees. Let's use sine 30 degrees to demonstrate this. So if you compute, we know that the sine of 30 degrees should give us 0.5. So we could quickly check that using the degree equivalent. That gives us 0.5. But what happens when we use sine 30? We realize that that evaluates to a different value. And that's because by default, MATLAB works in radians. So when you use the sine function as it is, the value of the argument expected here should be in radians. We could try with cosine as well. Now, cosine of 60 should be 0.5. But what happens here is you get a different value because this is being taken as a radian unit of measure. But what you actually want to do is cos d to show that what you're entering is a degree unit for the angle, and then when you put in 60, you obtain 0.5. Now the radian equivalent of these angles for sine is sine 30 is the equivalent is sine pi on 6. So you could straighten enter pi on 6, and then that should give you the correct value you are expecting, which is 0.5. For cosine, that should be pi on 3. Cos 60 is 60 degrees is pi on 3. So that should also give you the right answer. Now let's quickly run through the basic 6. There's tan, and in that case tan pi on 4, for instance. That is just tan 45. And we also have the inverse. Now these are not inverse. 1 over, so cosecant, and that's CSC. I'm going to use the same arguments for all of them. Pi and 4. And the second cotangent. Now, just to confirm, we can compute 1 over sec pi on 4. Sorry, kindly ignore this. What we actually want to do is 1 over sine pi on 4. And that confirms this is just the numerical inverse of the basic trig function. So this is 1 over sine, which is the cosecant, this value. And we could do the same for 1 over tan pi on 4. And that should give us the value we obtained for cotangent. So that just confirms that. Now, when it comes to the inverse trig functions, you compute that by placing a before the trig function. So arctangent is just a tan, and you pass the argument, it's pi and 4, whatever the argument is, you just pass that to the a tan. Now, if it's arcsine, it's a sine pi on 4. If it's arccosine, it's a cos. Likewise. And finally, we have the hyperbolic functions. We just take their usual form, sine h for the hyperbolic sine function, and then you pass whatever argument. So let's again use pi and 4. If it's cosine, cos h, tan h, and then so on. Pi and 4. And this includes all the members of the hyperbolic family. Now let's look at logarithms. So now this function log computes the natural log and not the log to the base 10 as we are used to in writing conventional math. In MATLAB, using the log function alone computes the natural logarithm of a number. And the way for us to quickly verify that is to bring its inverse, the exponential function, which we'll introduce in a bit, and then pass any argument to that exponential function. Then realize that the answer for this is just the argument, because the natural logarithm negates the exponential function. When it comes to log to any other base or log to base 10, you have to specify the base. So the usual log, conventional log in math, which is base 10, has to be specified using in this format, right? Log to the base 10, and then you pass the argument to the function, and that should give you the desired outcome. So we know that the log, just the bare form of the log, is the natural logarithm or log to the base e. And if you want any other logarithm, you specify the base right after writing log. So in this case, we know that log to the base 10, log to base 10 of 1 is 0. And we could do that for 10. That should give us 1. We could go again, 400, 1003, and so on. We could repeat this for any other base. So we could do log 2, 2 of 0, which is not a number. So log 2 of 1, that should give us 0. Then we could have log 2 of 2, which should give us 1. And we could go on from there. Now, beyond base 2, you need to use the change of log formula. And that simply requires you to divide the log of the argument by the log of the desired base. So in a simple case, if we want to log to the base 2 of 8, we could use, and you could use any log. You could use log 10, you could use the natural logarithm. So just for demonstration, log 2 of 8 should be 3. And I could also use the change of base formula to obtain this just by dividing log 8 by log 2. Right, so that means we could use this for any other one. If we want the log to the base 3 of 27, that's just log 27 divided by log. And that should give us a value. We could also use anything other than the natural logarithm. If you want to use log 10, that's also fine. 27 So that's all for logarithms. Now we move to the exponential function, which is quite straightforward. Simply exp. You know that exp0 should just be 1. So that is fine. exp1 should give us a value close to 2.7. And that's for the exponential function. There's also the absolute function, which gives you the positive value for any difference in a number. So we could do 1 minus 5, which should be a negative value otherwise, but for we apply the absolute value to give us the length or the magnitude, length magnitude, or the distance between 1 and 5. So that's it for the inbuilt functions in MATLAB. There are a lot more we've not covered in this particular lesson, but this is just to expose you to all the mathematical capabilities or some of the mathematical capabilities of MATLAB. Now, to cap it all off, we'll take an example that mixes some of these, most of these tools, operators. First, let's look at this. This should be 3. So there are 2 ways this could go. We want to see the precedence, order of precedence. If you either go to exponent 2 first, and that should give you 4, exponent 3, which should result in 64. Or this part is computed first, which is 8. 2 exponent 3 is 8, and then 2 exponent 8 is a number around 256. So what we see here is you have 64. So essentially the indices stack on each other, right? So this is 2 exponent 2, exponent 3. Right? Now for our next example, we're just going to study it and try to predict what the outcome would be, and then we run it. So over here we have a few operations of different kinds. There are comparative operators, the usual arithmetic, the logical operators, among others. So let's take the easiest part first. Now this is simply square root of 4, which should give us 2, and this is a logical operator comparing both. So this should evaluate to a true statement. And remember that a true statement is indexed in MATLAB by 1, as represented in MATLAB by the numerical value 1. So this side is a true statement and it's also 1. Now let's look at the left side. It's a bit more complicated, but we'll break it down into smaller chunks. There's 3 minus 2, which is 1. And this statement says 5 is greater than 1. So that should also be true on one hand. Now this over here, we have the OR operator. So let's move on to the other side of that operator. We have 2 plus 5, which is 7. And this says is greater or equal to 8, which is false. And recall for the OR operator, you need either of the statements to be true to result in a true statement. So for the condition to be met, we need this to be either of these, one or this to be true. And once we have one side true, then this whole thing evaluates to a true statement. So even though this side is false, this is true, and this should, everything in this bracket should give us a true statement. And if you remember the way the AND operator also works, it requires both sides to be true for the condition to be met. So we have true coming from this and then true from this side. And that means this at the end of the day is a true statement. However, we have the NOT operator here, which should negate our answer or invert whatever logical answer we get. And so that we expect a false statement at the end of all of this. I'm just going to copy this. It's going to take some time to type, so I'm just going to copy it, paste, and yes, we end up with a false statement or 0, which represents false in MATLAB. Now this concludes the first part of our introductory lesson on MATLAB for engineers. We are going to look at data types and variables in the other part, and then finally bring the introductory session to an end. So I'll see you there.